Hello, today we're going to talk about transport protocols, and we're going to talk about TCP and UDP. Transport protocols are used in the OSI model after the session layer has begun and opened the session. Your data is going to need to be packaged in such a way that it's either going to require there be a response or communication from the receiving host that the data in fact arrived, or you're going to just take the assumption that the data arrived on the other side. So at the transport layer of the OSI model, the type of transport protocol that needs to be selected will be done at this time. So TCP, or Transmission Control Protocol, is the one that you would use when you need to know that data has been received on the other side. For example, if you're sending a login request to a web server, you'd want to know that this connection has been established prior to you going ahead and sending your login name and your password. On the same time, if you're going ahead and you're streaming a video from Netflix or streaming music from Pandora or Amazon Music, you don't need to have confirmation that every packet's been received, because if you do, it's going to slow that down considerably. So the type of data that gets used will determine the type of protocol or transport protocol that's used. Now, the transmission control protocol, if you notice from this diagram right here, there's a lot of information that gets placed in, and the user datagram protocol actually has very little. They both do data. They both have ports, source and destination. We'll talk more on those in a minute. But over here in the TCP header, there's some other things that have to happen. And the first thing that has to happen is there has to be what we call a TCP IP handshake. So in TCP, one of the ways that the two hosts agree that they have a communication is to do something called the three-way handshake. Now, if you notice over here in the actual segment itself, you have an area here. These are the flags. Okay? And in these flags, they can either be set on or off. And the flags that we're going to look at is a flag called SYN and a flag called ACK. In a three-way handshake, you're going to have a three-step process. In the first step is the first computer here is going to send what is called a SYN. And this SYN is going to be sent over to the receiving computer. At that time, the receiving computer is going to acknowledge that SYN, and it's going to then send its own SYN back. And so this will go back over to the sending computer, and the sending computer will complete the three-way handshake, and it's going to send over an ACK back saying, I acknowledge your acknowledgement. This has to occur for the three-way handshake to happen. Once that does, we have now considered ourselves to have an established connection. But let's see what this looks like in Wireshark. Wireshark is a protocol analyzer, a packet sniffer. And so what we're going to do is we're going to go ahead and we're going to look at just some TCP packets. And if you notice right here in the brackets, you're going to see things like FIN and ACK and so on. So if we look close enough, we're going to be able to see a SYN, an ACK, and an ACK. We can see one right here. So if I go ahead and I double click on this packet and drag it over to our screen, what we have here is in the transmission control protocol section, down here we have the flags, and you can see the flag for SYN is set on. So this is the first step in this three-way handshake. And Wireshark does a nice job of bringing this all out to us. Then the SYN ACK is going to occur. So we're going to go ahead and we're going to double click on this one, and it has now said, all right, I received your SYN. I'm going to acknowledge it, and I'm going to send you my own SYN back. This is step 2 of the three-way handshake. And then, of course, the final step is the ACK, where the sending computer, again, has sent back the flag of ACK turned on, and this completes the three-way handshake. Following this, you could see then HTML, a GET command was issued. Transaction's going to continue as normal, whatever it is that happens to be going on. But before they can establish this connection, this three-way handshake had to occur. And you notice right here, This is the sending computer. This was the SYN-ACK, the destination, and then here was the ACK again. And that is what we call the three-way handshake. And the final piece we're going to talk about in this video are ports. Now, ports are labeled as either the source port or the destination port. The source port will identify where something is coming from, and the destination port will identify where something is going to. You notice that there are ports listed both under TCP packets, and there's going to be ports listed also as well under UDP packets. There are 65,535 available TCP ports on a host computer, as well as 65,535 UDP ports on a host computer. So what do these ports do? What is their purpose? Basically, a port is considered, think of it like an apartment. I can give you the address of the apartment building, but the individual apartment that a friend might live in is going to be identified by a sub number. And so in this case, the apartment number would be like a port. So we use ports in computers and networking to identify the services that are used. And so if you're studying for the A+ test, there's some specific ports that you want to be aware of. So let's take a look at those. And we'll make this a little bit bigger. All right. The ports that are listed here, you'll notice that they vary in different numbers. First thing you want to know about ports, however, is that there are three types or categories of ports. There are what we call well-known ports. These range from anywhere from port 0 through port 1023. We have dynamic ports, which go from 1024 to 49,151. And the last one is a port called an ephemeral. And it's actually pronounced differently than it's spelled. And these ports go from 49,152 to 65,535. These ports will vary based upon how they're being used. For example, the ports that you see listed here, these are all, generally speaking, except for 3389, what we call well-known ports. That means these ports are typically associated with only this service. So if you have port 80, you're associating that with an HTTP request, probably on a web server. So you want to be familiar with not only the port, but what the port is used for. So FTP, you got to go back and remember what your services are. FTP stands for File Transfer Protocol, and it is a service that allows you to upload and download files to a special server called an FTP server. 22 and 23 deal with remote management. The difference between SSH and Telnet is security. SSH, if you're going to SSH into, say, a switch or a router, you're going in a secure fashion, you're encrypting your communications. Where Telnet on port 23, you can remote into a router or switch to manage it, but anybody who has a protocol analyzer or a packet sniffer could read those transactions. So it's definitely not secure. Port 25, this well-known port stands for Simple Mail Transfer Protocol. And it basically is the port used for one mailbox to contact and communicate with another mailbox on another system. Port 53 is DNS. So whenever you want to send a request or a lookup for DNS, it's going to send the destination port out as 53. And we'll take a look at that in just a second. Port 80 is associated with HTTP. And I'm going to jump up and tell you that HTTPS, the secure form, the encrypted form, is port 443. Ports 110 and 143 are both associated with email. 110 is used with POP, Post Office Protocol, version 3. POP is, think of it this way, the P in POP, P for push. This is what the emails on an email server would be pushed down to the client computer and be stored locally. IMAP, think of the I as internet. And what this would do is this would keep those mail messages on the mail server. So for example, if you're using Gmail, you can check your Gmail messages from your phone or go to a computer, and they're all going to still be on the server. IMAP is what's keeping them up there. RDP stands for Remote Desktop Protocol. So if you're going to use the Remote Desktop Protocol to make a remote connection, again, maybe for tech support or management, that port would need to be open on the remote site. NetBIOS is a legacy Microsoft communication protocol, and it actually uses a range of protocols from 137 through 139. SMB or CIFS, port 445. This is a protocol, server message block, that if you are sharing a folder or sharing a printer, you would need SMB open to make that happen. Port 427 stands for Service Location Protocol. Probably not well known anymore, but it used to be a very popular port because we used it with a networking system called Novell. And Novell was an extremely popular network operating system that since mostly have been replaced with Linux and Microsoft Server. Same thing for 548. This is the protocol used for Apple File Talk protocol. So if you had two Apple devices, they could use this protocol to communicate. Nowadays, TCP IP has mostly taken over this communication here, and as well as with Novell NetWare. Port 67 and 68 is used by DHCP. So if your client is sending a request for a lease, you're going to enter, that request is going to leave your computer on port 68, and it's going to enter on the DHCP server on port 67. So 68 is DHCP client, 67 DHCP server. LDAP stands for Lightweight Directory Access Protocol, port 389. This protocol is used to help manage databases of resources on networks, including usernames, passwords, printers, things like that. And finally, SNMP, Simple Network Management Protocol. This is a protocol used by a system when you are trying to find information, trap or capture information so that you can manage your network by collecting information as it goes across your network. And again, just to show you how this looks, let's bring up our Wireshark again. And this time I'm going to go ahead and I'm going to do a filter for just DNS packets. And you can see that query is asking for something. So in this example, we're doing a query. We're asking for the IP address for reddit.com. So if I double click and I open this, and I look at my user datagram protocol, because this one is UDP, you can notice that the destination port is 53. The source port really doesn't matter. It was a temporary ephemeral port that is used only so that when the reply is made, it knows where to send that reply back to. So here is the question: what is the IP address for reddit.com? It was a query, and the response is in 1411. So let's take a look. So we'll go down to 1411. Now the source port is 53 because it's coming from the DNS server, and it's going to that temporary ephemeral port of 64,863 to receive that information, and it's going to go ahead and get your DNS answer. So we need ports. They're used with TCP and UDP transactions. We are these are the ports that you are most likely to see, especially taking a A+ test. And so these are the ones that you want to be most familiar with. And make sure you understand that ports are assigned at the transport layer of the OSI model, and you want to be familiar with both the service and the ports number that it is running on.